Good afternoon. So today we want to apply all the rules of what? Of logarithm to solve examination problems. Okay, let's start. Now look at this. Log, let me change my pen. Sorry, I want to use right. Log 8 base 2. Can I see this is base 2? This is base 2. This is base 2. So you can see, and this is addition, this is subtraction. So we can use addition and subtraction law. We can do both of them at the same time. Log to base 2, that's the common thing there. Now, the first one is plus. So the power are going to be multiplied 8 times 16. Followed by what? Minus. Minus is division. So the power that follow that minus will be divided by 4. And we have log to base 2. Now this here 2. That is 2 times 16. That is 32. Good. And how many times? The question now is how many times are we going to multiply 2 to give 32? Let's try it. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. That is 5 times. So this is 2 raised to power 5. So our 5 can come here and we have 5 log 2 base 2. And 2 base 2 is 1. So our answer is 5. So that's why immediately I see this, I already know my answer. I'll just ask myself, how many times am I going to multiply 2 to get 32? 5 times. So my answer is 5. It's as simple as that. But there is a particular law we can still use also, because you may use a method, you get your answer. Another student use another method and still get his answer. So far, we are all obeying the rules appropriately. Now, let's solve this again. I want to solve it another way. Remember that law I told you that I will be using a lot to simplify. I can write this. This is 2 raised to power 1. And this is 2 raised to power 3. Plus log 2 raised to power 1. 2 raised to power 4. Minus log 2 raised to power 1, 2 raised to power 2. I said we are going to be dividing their powers. So this one is going to be 3 divided by 1. 3 over 1. That's what is left, log 2 base 2. That's going to give us 1. Plus the power of this, 4, and the power of this, 1. So that's going to be 4 over 1. And you can see the remaining one is going to be 4 over 1 log 2 base 2. That is 1. Don't bother to put that. Minus the power of this is 2. The power of this is 1. Minus 2 over 1. So now 3 plus 4, 7. 7 minus 2. That's 5. You see, we still get our answer. When we make both the number that we want to find the logarithm and the base, when we make both of them index number, make them indices, then we can just take their power and divide. That's very, very beautiful law. So let's go. Without using table, we are asked to evaluate this. Look at this question is different from the previous one. How? Look at this. The base are different. Can you see that the base are different? So in this one, you cannot use addition law or subtraction law because the base are different. We can solve this individually, or we just use that method we just did now. Okay, let's even use it from the law of this thing. I told you that this thing is very, very simple. Okay, I told you earlier when we started, I said, if you ask yourself this kind of question, you get your answer easily. Okay, let's look at it. The first one, how many times are we going to multiply 2 to get 4? 2 times 2, that is 2. Plus, how many times, what power are you going to give to 4 to make it 2? That is half, because when you find square root of 4, that's where you get what? 2. And square root means fractional power. So that is 4 raised to power half. That will give us 2. So this is half. Minus, what power are you going to give to 25 to make it 5? You are going to give it power of half also. 25 raised to power half. That's square root of 25. That is half. Can you see? 2 plus half minus half. So our answer is 2. So our answer is what? 2. So our answer is what? 2. Now, we can do something. Let's use that other method I told you I love to use, that find method. I can say log 2 raised to power 1. I'm writing them as indices. 4 is 2 raised to power 2 plus log 4 2 raised to power 2 plus 2 raised to power 1 minus log 5 raised to power 2 then 5 raised to power 1. Now you can see I take the power of this over this, 2 over 1 plus power of this to this, 1 over 2 minus power of this to this, 1 over 2. I say plus half minus half, that's gone. 2 over 1 is 2. But you get the same answer. So let's go. We can do this also with that method easily. Log, I can write this log 3 raised to power 1, 3 raised to power 3 minus log. This, if you write this one in indices, 1 over 4 is 2 raised to power minus 2. And 64 is 2 raised to power 6. 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2 times 2 times 2 times 6, 32 times 2, 64. Yeah, we are right. 2 raised to power 6 over log 3 raised to power 1. 1 over 81. You know 81 is 3 times 3 times 3 times 3. 3 raised to power 4. So 1 over 81 is going to be 3 raised to power minus 4. So we can take the power of this, that's 3 over 1 minus power of this, divided by this, minus 6 over minus 2. Then I'm going to divide my answer by whatever I get here. Okay, this is minus 4 over 1 minus 4 over what? 1. So now, minus times minus, this is going to give us plus. So 6 over 2 is what? 3. 3 plus 3 is 6. 6 divided by minus 4 over 1 is minus 4. So our answer is going to be, we divide by 2, that's going to be minus 3 over what? Over 2. That is minus 1.5. So this law is very, very easy to apply and it makes work easier. Now, we want to look at this. Sometimes when you cannot compute the logarithm directly, they can give you what the log is. Now, look at this. Now, they give us log 2 is equals to 0.3010 and log 7 equals to this. They want us to get log 112. I have to break this down to know how many 2 we are going to find there. 2 here, 56. 2 here, 28. 2 here, 14. 2 here, 7. 7 here, 1. Can see we have how many 2? We have 2 raised to the power of 4 multiplied by 7. So that's all I need. So I can erase this part. I don't need it again. This is just what I need there. Now, instead of writing log 112, then I'll write log 2 raised to the power 4 times 7. And you know that we can express addition as product. So now that we need product as addition, we express it as addition. So this is going to be log 2 raised to the power 4 plus log 7. You can see here we are not even showing the base. Yes, whenever they just write log 112 like this, it means log 112 base 10. They are all base 10. Once they don't write the base, it is base 10. So now we don't bother to write it. So this one, the power of this one can come to the back. That will be 4 log 2 plus log 7. Now they told us that log 2 is what? Log 2 is 0.30, 0.3010 plus log 7, 0.8451. So we can what? We can just yeah, we can press our calculator to get this. So our calculator, 4 multiplied by 0.3010, then plus 0.8451. So our answer is going to be 2.0491. 2.0491. See how easy this is? We still have another similar question, but this one is even simpler. You can see this is log 4 raised to power 1 over 3 base 10. You can see this is one of the law that we learned about finding what? Finding index number. Finding index notation number that is in index notation or an exponent. 4 raised to power 1 over 3. If you want to do this, we bring the power down. The law says we bring the power down. So this is the same as 1 all over 3 log 4. 4 will still be there, base 10. And we have already been given log 4 base 10. So that means 1 over 3 multiplied by 0.6021. So we just punch our calculator for this. Or we can even divide this indirectly. 3 in 0 is 0. 3 in 6 is 2. 3 in 0 is 0. 3 in 2 is 0. 3 in 21, 7. So our answer is going to be 0.2007. Now, here, if log this equals to this, evaluate this. If you press your calculator, you discover that when you are looking for log 77.5, log 75, log 750, log 7,500, so far it is having that digit 75. It is the number before the decimal point that will be changing. Now, here you have one number, 7.5, log 7.5 is 0 point. So log, when you have 2 digits before the decimal point, when you have 1 digit before the decimal point, we are going to have 0 point. When we have 2 numbers before the decimal point, we are going to have 1 point. If you have 3 numbers, we are going to have 3 points. So what does it mean? It means that log 75 is going to be 1.8751. Log 750, that is 3 digits before the decimal point. 750 is going to be 2.8751. And the law says that we should multiply 75 by 2, this one times 2. Then we add it to 750. So let's do that. Let me bring out the calculator. So we have 1.875 times 2. No, 1.875 times 2 plus 2.8751. So we have 6.6253. And that's our answer. All the one that we have been doing, they are simplification, simplification, simplification. So now we want to solve an equation. That is, this one has equals to mark now. This is very, very beautiful. You can see you cannot solve this one using that method I normally use because there is no how you are going to express 18. as an index number. You cannot expect 18 as an exponent. So we're going to use our addition law to do that. Okay, so we're going to have log, all the bases are equal. So that's beautiful. We use our addition and what? Subtraction law. It's going to be 18 times 3. For the plus part, we multiply. For the subtraction part, we divided by x equals to 3. You can see I'm having this one to be base 3. I can make both all these ones here. I can make all of them power of 3. Power of 3 so that it can destroy the log. And I also make this one power of 3. So this is gone like this. So I have 13 times 8 times 3. That is 54 over x. 3 raised to power 3 is 27 over 1. So if I cross multiply, this will cut this, that's going to be 2. So if I cross multiply, x is going to be what? 2. It's as simple as that. I want to solve this equation also. How do you go about this? Yeah, you can use both of them as power of 3. I'm using them as power of 3 because I have base 3 in the log so that the log can disappear. So I've used this as power of 3 now, and I'm going to make minus 8 also power of 3. Now the logarithm is gone like that. So I have x squared. So x squared is now equals to 3 to the power minus 8. Now I can divide the power by 2. If I divide the power of this one by 2, the power will become 1. If I divide the power of this one by 2, the power will become 4. And I still divide by 2. That is 4. So now we know that 3 raised to the power 4 is 81. So 3 raised to the power minus 4 is going to be 1 over 81. Now this is a very, very beautiful question. A very, very beautiful question. Now if log 10 base 8 is equal to x, evaluate log 5 base 8. You can see they are both base 8, base 8. We can break down log 10 so that into 5 and something and be able to get that. Let's say I can write log 10 base 8. I can write it as log 5 base 8 plus log 2 base 8. How did I do that? Because I know that addition will make the power multiply. Addition will make the number at the top multiply. 5 times 2, that's what? 10. So we're going to get 10 base 8 back. So this is it. And look at it here. They want me to find this one now. And they already told me that this one is x. So x equals to log 5 base 8 plus, how do you solve this one? You can just quickly use that method I told you about, that very simple method. You can write 3 as an index number, 2 raised to the power 3. And you can write 2 as an index number, 2 raised to the power 1. So 1 over 3. So that's going to be 1 over 3. So now I can take this one to this side. So I'm going to have x minus 1 over 3 equals to log 5 base 8. So that's what they asked me to look for. Log 5 base 8 is what they asked me to look for. And it is what? X minus 1 over 3. They say in terms of x. So x is in the answer. So thank you very much for your time. Please attempt more questions and you are going to what? You are going to be able to apply more of the what? Rules. Please and please, all these laws of logarithm, use the one that is most convenient for you. Now, the most convenient for me is that index, writing both of them as exponents, writing both of them as indices. Then I take their powers. That is very, very easy for me, so I use it. And how to clear the logarithm, I make use of both sides. I just use them as the power of what is in the base. What I do to the left-hand side, I do to the right-hand side, and I get my answer very fast. So you can attempt your question, and if you have some challenges, let me know so I can help you out. Thank you very much for your time.